Hey, it's another screencast with an example of an indeterminate form calculated using L'Hopital's rule. In this example, I want to calculate the limit as x goes to 1 of x over x minus 1 over log x. So this example will be a case of an indeterminate form of type infinity over infinity. We'll see that this is going to infinity and this is going to infinity. To see that, notice here the log, or x is going to 1, and let's change this. Let's say this is going to 1 from above. Here, x is going to 1 from above, so log x is going to 0 from above. So this whole thing here is going to infinity. Positive infinity. Meanwhile, the other term, the numerator is going to 1 from above, and the denominator down here, it's going to 0 from above. So the quotient is always positive, but the denominator is getting smaller and smaller, so this whole thing is going to positive infinity. So our indeterminate form here looks like infinity minus infinity. A true indeterminate form. So we need to calculate it. We need to resolve it. And the way we're going to start it, it looks like here, we're going to just try algebra. So let's just do algebra on the expression inside the limit. All right, I'm going to write this as a single fraction. So that would be x log x minus 1 times x minus 1, right? Cross multiplication, as it were. And the denominator is the common denominator, x minus 1 times log x. So let's just simplify once and check to see if this is a proper indeterminate form. So let's look. As x goes to 1 from above, this x is going to 1, so it cancels with that other 1. This x is going to 1, and this log is going to 0, so my whole numerator is going to 0. And downstairs, this x minus 1 is going to 0, and log x is going to 0, so the denominator is also going to 0. So indeed, we have an indeterminate form of type 0 over 0, and that's one of the kinds that we can apply L'Hopital's rule to. So let's do it. So applying L'Hopital's rule, since the numerator and the denominator of the previous limit are both differentiable functions, we can replace them with their derivatives for the sake of this limit calculation. So upstairs, I've got to use the product rule, so that's log x plus x times 1 over x, and then derivative of 1 is 0, and the derivative of negative x is negative 1. Then downstairs, the product rule, I get the log x plus x minus 1 times 1 over x. So if we clean this up, right, there's no 0 there. This is 1, so it'll cancel with the negative 1 there. That's good. And I think that's about all the simplification I can do. I could rewrite x minus 1 times 1 over x as 1 minus 1 over x. Now let's check what's happening as x goes to 1. My numerator is going to 0, and my denominator, this is going to 0, and that's going to 0. So I still have an indeterminate form of type 0 over 0. So I'm going to apply L'Hopital's rule again. And so in my numerator, I get 1 over x. In my denominator, I get 1 over x plus 0 minus, plus actually 1 over x squared. Because the derivative of 1 over x is negative 1 over x squared. And remember, what I'm doing here, when I say I'm applying L'Hopital's rule, what I'm going to do is I'm going to replace the numerator with its derivative and replace the denominator with its derivative, right? Because the values of those limits should be the same. Now I'm running out of vertical room, so forgive me as I move over to the right. but no, I can do it this way. As x goes to 1, my numerator here is going to 1, and this goes to 1, and this goes to 1. So it looks like my limit here is 1/2. Interesting. And now I'm done. I've just calculated this limit of an indeterminate form of type negative or infinity minus infinity. I've used L'Hopital's rule twice and come up with an answer of 1/2. So there you go. See you in class.